Hello everyone, I am Shujata Kundu, Assistant Professor of Department of Information Technology of Nadula Institute of Technology. In this lecture, we will study multimedia input-output technologies, digital voice and audio, video image and animation, full motion video, storage and retrieval technologies. So first of all, we will study multimedia input-output technologies. The wide ranges of input and output devices are available for multimedia. An input device is the hardware mechanism that transforms information in the external world for consumption by a computer. Whereas an output device is a hardware used to communicate the result of data processing carried out by the user or CPU. So first of all, we will discuss input device. Often, input devices are under direct control by a human user who uses them to communicate commands or other information to be processed by the computer, which may then transmit feedback to the user through an output device. Human uses input devices to communicate commands or other information to be processed by the computer. Input and output devices together make up the hardware interface between a computer and the user or external world. Typical example of input devices include keyboards and mic. In general, any sensor which monitors, scans for and accepts information from the external world can be considered an input device, whether or not the information is under the direct control of a user. Next, we will talk about classification of input devices. Input devices can be classified according to the modality of input. For example, mechanical, motion, audio, visual, sound, etc. Discrete input, whether the input is discrete like key process or continuous, that is a mouse position, although digitized into a discrete quantity, is high resolution enough to be though as continuous. Direct or indirect input, whether the input is direct or indirect. With direct input, the input space coincides with the display space. That is, pointing is done in the space where visual feedback or the cursor appears. Touchscreens and light pens involve direct input. For example, involving direct input include the mouse and trackball. Absolute or relative positional information, whether the positional information is absolute, that is on a touch screen, or relative, which is with a mouse that can be lifted and reposited. Note that direct input is almost necessarily absolute, but indirect input may be either absolute or relative. For example, digitizing graphics tablets that do not have an embedded screen involve indirect input and sense absolute positions and are often run in an absolute input mode, but they may also be set up to simulate a relative input mode where the stylus can be lifted and repositioned. Next is keyboard, the input device. A keyboard is the most common method of interaction with a computer. Keyboards provide various tactile responses from firm to mushy and have various layouts depending upon your computer system and keyboard model. Keyboards are typically rated for at least 50 million cycles. The most common keyboard for PCs is the 101 style, which provides 101 keys. Although many styles are available with fewer special keys, LEDs, and other features. For example, of some types of keyboards include computer keyboard. It can be corded or wireless. The original PC keyboard with 84 keys, the AT keyboard also with 84 keys, and the enhanced keyboard with 101 keys. The last three keyboards have some different in the placement of functional keys, the control keys, the return key, and the shift key. Next, we will talk about pointing device. Pointing device of any computer hardware component, especially human interface device, that allows a user to input spatial, that is continuous and multidimensional data to a computer. CAD systems and graphical user interfaces, that is GUI, allow the user to control and provide data to the computer using physical gestures like point, click, and drag, typically by moving a handheld mouse across the surface of the physical desktop and activating switches on the mouse. While the most common pointing device by far is the mouse, many more devices have been developed. Mouse is commonly used as a metaphor for devices that move the cursor. A mouse is the standard tool for interacting with a GUI. Even though the Windows environment accepts keyboard entry in lieu of mouse, point and click actions, your multimedia project should typically be designed with the mouse or touchscreen. The buttons of the mouse provide additional user input, such as pointing and double-clicking to open a document, or the click and drag operation, in which the mouse button is pressed and held down to drag or move an object. Examples of common pointing devices include mouse, touchpad, space ball, touchscreen, light pen, eye tracking devices, directional pad, joysticks, etc. Next, we will discuss composite device. Input devices such as buttons and joysticks can be combined on a single physical device that could be thought of as a composite device. Many gaming devices have controllers like this. Example of composite devices include game controller, game pad or joypad, paddle, that is game controller, etc. Next, we will talk about imaging and video input device. Video input devices are used to digitize images or video from the outside world into the computer. The information can be stored in a large number of formats depending on the user's requirement. For this purpose, we can use scanners. Scanner may be the most useful piece of equipment used in the course of producing a multimedia project. There are flat-bed and handheld scanners. Most commonly available are grayscale and color flat-bed scanners that provide a resolution of 300 or 600 dots per inch, that is DPI. 600 or 300 DPI. Professional graphics houses may use even higher resolution units. Handheld scanners can be useful or for scanning small images and columns of text, but they may prove inadequate for the multimedia development. So be aware that scanned images, particularly those at high resolution and in color, demand an extremely large of storage space on the hard disks, no matter what instrument is used to do the scanning. Most expensive flatbed scanners offer at least 300 dpi resolution, and most scanners allow to set the scanning resolution. Scanners helps to make clear electronic images of existing artwork such as photos, ads, paint, drawings, cartoons, etc. And it can save many hours when you are incorporating proprietary art into the application. Scanners also give a starting point for the creative diversions. The devices used for capturing image and video are webcam, image scanner, fingerprint scanner, barcode reader, 3D scanner, etc. Next, we will discuss audio input devices. Audio input devices are used to capture audio clips, and these audio clips can be captured by using some electronic devices like microphone, speech recognition, etc. Note that MIDI, that is musical instrument digital interface system, which allows musical instruments to be used as audio input devices as well. Next input device is touchscreens. Touchscreens are monitors that usually have a textured coating across the glass face. This coating is sensitive to pressure and register the location of the user's finger when it touches the screen. The touch mat system, which has no coating, actually measures the pitch, roll, and the rotation of the monitor when pressed by a finger, and determines how much force was exerted and the location where the force was applied. Other touchscreens use invisible beams of infrared light that crisscross the front of the monitor to calculate where a finger was pressed. Pressing twice on the touchscreen is quick and dragging the figure without lifting it to another location simulates a mouse click and drag. A keyboard is sometimes simulated using on-screen representation, so users can input names, numbers, and other text by pressing keys. When your project is designed to use touchscreen, the monitor is the only input device required. So you can secure all other system hardware behind locked doors to prevent theft or tampering. And I think all of you know about touchscreen because all of your phone right now is a smartphone and you all are using touchscreen. So all of you are very eagerly waiting to know what is touchscreen, or I think all of you already know what is touchscreen. So next is output device. Presentation of the audio and visual components of the multimedia project requires hardware that may or may not be included with the computer itself: speakers, amplifiers, monitors, motion video devices, and capable storage systems. Better the equipment of course will better the presentation also. There is no greater test of the benefits of good output hardware than to fit the audio output of your computer into an external amplifier system. Suddenly, the bass sounds become deeper and richer, and even music sampled at low quality may seem to be acceptable. Next is audio device. All computers equipped with an internal speaker and a dedicated sound clip, and they are capable of audio input output without additional hardware or software. Digitizing sound on the Mac requires an external microphone and sound editing or recording software such as Sound Edit 16 from Macromedia, Alchemy from Passport, or Sound Designer from DigiDesign, etc. To take the advantage of built-in stereo sound, external speakers are required. Next, we will talk about amplifiers and speakers. Often the speakers used during a project's development will not be adequate for its presentation. Speakers with built-in amplifiers or attached to an external amplifier are important when the project will be presented to a large audience or in a noisy settings. So that time it will be very helpful. Next we will study monitors. The monitors are used to develop the multimedia projects depend on the different type of multimedia applications created as well as what computer is being used. A wide variety of monitors is available for PCs. High-end large screen graphics monitors are available and they are expensive also. Multimedia developers will often attach more than one monitor to their computers using add-on graphic board. This is because many authoring systems allow working with several open windows at a time. So, we can dedicate one monitor to viewing the work we are creating or designing, and we can perform various editing tasks in windows on other monitors that do not block the view of your work. Editing windows that overlap a work view when developing the Macromedia's authoring environment. Director on one monitor. So that time it will be overlapping. Developing in director is best with at least two monitors, one to view the work, the other to view the score. A third monitor is often added by director developers to display the cast. Next, we will discuss video devices. There is no other contemporary message medium has the visual impact of video. With a video digitizing board installed in a computer, we can display a television picture on your monitor. Some boards include a frame grabber feature for capturing the image and turning it into a colored bitmap, which can be saved as a PICT or TIFF file and then used as part of a graphic or a background in your project. Display of video on any computer platform requires manipulation of an enormous amount of data when used in conjunction with video disk, which give precise control over the images being viewed. Audio cards, you place an image into a window on the computer monitor. A second television screen dedicated to video is not required, and video cards typically come with excellent special effects software. There are many video cards available today. Most of this supports various video in a window size. Identification of source video, setup of play sequence are segment special effects. Frame grabbing, digital movie making, and some have built-in television tuner also. Whether you delivered your video from tape using Visca controls, from video disc, or a QuickTime or AVI movie, it is important that your source material be of high quality. You have to remember that if your source material should be high quality, then you will get a good video. Next, we will discuss projector. When it is necessary to show a material to more viewers than can huddle around a computer monitor, it will be necessary to project it onto large screen or even a white painted wall. CRT projectors, LCD panels attached to a overhead projector, standalone LCD projectors and light bulb projectors are available to splash the work onto big screen surface. CRT projectors have been around for quite a while. They are the original big screen televisions. They use three separate projector tubes and lenses, that is red, green and blue, and three color channels of light must converge accurately on the screen. Setup, focusing and aligning are important to getting a clear and crisp picture. CRT projectors are compatible with the output of most computers as well as televisions. LCD panels are portable devices that fit in a briefcase. The panel is placed on the glass surface of a standard overhead projector available in most schools, conference rooms of an institute, and meeting halls, etc. While the overhead projectors does the program work, the panel is connected to the computer and provides the image in thousands of colors and with active matrix technology at speeds that allow full motion video and animation. Light bulbs complete Light bulbs complete the high-end CRT projectors and use a liquid crystal technology in which a low-intensity color image modulates a high-intensity light beam. These units are expensive, but the image of a light wave projector is very bright and color saturated. It can be projected onto screen as wide as 10 meters. Next is printer. The advent of reasonable priced color printers, hard copy output has entered the multimedia sense. From storyboards to presentation to production of collateral marketing material, color printers have become an important part of the multimedia development environment. Color helps clarify concepts, improve understanding and retention of information, and organize complex data also. As multimedia designers already know, intelligent use of colors is critically to the success of a project. Tektronix offers both solid ink and laser options, and either phases 560 will, that is 560 will print more than 10,000 pages at a rate of 5 color pages or 14 monochrome pages per minute before requiring new toner. Most printer manufacturers offer a color model just as all computers once used monochrome monitors, but are now color. All printers will become color printers. Next, we will discuss digital voice and audio. Sound is made up of continuous analog sine waves that tend to repeat depending on the music or voice. The analog waveforms are converted into digital format by analog to digital converter, that is ADC. Digital audio is created when a sound wave is converted into a process referred to as digitizing. It is possible to digitize sound from a microphone, synthesizer, existing tape recordings, live radio, television broadcasting, popular series. You can digitize sounds from a natural source or pre-recorded. The quality of this digital recording depends upon how often the samples are taken. Prepare digital audio files. Preparing digital audio files is straightforward. If you have analog source materials like music or sound effects that you have recorded on analog media like cassette tapes, the first step is to digitize the analog material and recording it onto computer readable digital media. It is necessary to focus on two crucial aspects of preparing digital audio files. One is balancing the need for sound quality against your available RAM and hard disk resources. And another one is setting proper recording levels to get a good clean recording. Remember that the sampling rate determines the frequency at which samples will be drawn for the recording. Sampling at higher rates more accurately capture the high frequency content of your sound. Audio resolution determines the accuracy of which a sound can be digitized. Next, we will discuss determine the size of the digital audio. Formula for determining the size of the digital audio. But before discussing the formula, we have to know some prerequisites. Sampling is a process where the analog signal is sampled over time at regular intervals to obtain the amplitude of the analog signal at the sampling time. The regular interval at which the sampling occurs is called the sampling rate. The sampling size is the amount of information stored. This is known as bit resolution. The number of channels is 2 for stereo and 1 for monophonic. The time span of the recording is measured in seconds. Now we can calculate the sound using these formulas. If the sound is monophonic, the formula is sampling rate multiplication with the duration of recording in seconds multiplied with the bit resolution by 8 into 1 as because it is for monophonic sound. If the sound is stereo, the formula will be sampling rate into duration of the recording in seconds into bit resolution by 8 into 2. 2 for stereo sound. Next we will discuss video image. Video is the visual multimedia source that combines a sequence of images to form a moving picture. The video transmits a signal to a screen and processes the order in which the screen captures should be shown. That is, the video transmits a signal to a screen and processes the order in which the screen captures should be shown. Studio usually have audio components that correspond with the pictures being shown on the screen. Next we will discuss video image. Video is the visual media source. We have already discussed video image. So now digital video has supplanted analog video as the method of choice for making video for multimedia use. While broadcast stations and professional production of post-production houses remain greatly invested in analog video hardware, digital video gear produces excellent finished products at a fraction of the cost of analog. A digital camcorder directly connected to a computer workstation eliminates the image degrading analog to digital conversion step typically performed by expensive video capture cards and brings the power of nonlinear video editing and production of everyday uses. Next we will discuss animation. Animation consists of still images displayed so quickly that will give the impression of continuous movement. The screen object is a vector image in animation. Computer animation programs typically employ the same logic and procedure concepts as cell animation using layer, keyframe, and tuning technologies, and even borrowing from the vocabulary of classical animators. On the computer, paint is most often filled or drawn with tools which features such as gradients and anti-aliasing. The word links in computer animation terminology usually means spatial methods or computing RGB pixel values, provide edge detection and layering so that images can blend or otherwise mix their colors to produce spatial transparencies, inversions, and effects. The primary difference between the animation software program is in how much must be drawn by the animator and how much is automatically generated by the software. In 2D animation, the animator creates an object and describes a path for the object to follow. The software takes over, actually creating the animation on the fly as the program is being viewed by your users. In 3D animation, the animator puts his effort in creating the models of individual and designing the characteristics of their shapes and surfaces. Paint is most often filled or drawn with tools using features such gradients and anti-aliasing. Next, we will discuss an important topic, full motion video. Full motion video, usually abbreviated as FMV, is a popular term for pre-recorded TV quality movie or animation in a video game. FMV is simply a playback of something that was previously recorded, usually rendered by a much more powerful machine. Thus, FMV was traditionally much higher quality than real-time cutscenes. Cutscenes means a cutscenes or event scene is a sequence in a video game that is not interactive. And the two can usually be differentiated by this. With computer games running on more modern hardware, however, the use of FMV, that is full motion video for cutscenes, has been drastically reduced as similar quality graphics can be produced in the game engine with much less disk space required for the source data. Next, we will discuss storage and retrieval technologies. Multimedia storage, that is, multimedia data can be stored in the mediums such as optical discs, hardware drives, magnetic storage media, etc. Whereas data retrieval depends on the type of multimedia files, which can be continuous or discrete. Storage, a data storage device, is device for recording or storing information data. Multimedia systems require storage for large capacity objects such as video, audio, and images. Recording can be done using virtually by any form of energy, spanning from manual muscle power in handwriting to acoustic vibrations in phonographic recording, to electromagnetic energy modulating magnetic tape and optical discs. Data retrieval means obtaining data from a database management system. In this case, it is considered that data is represented in a structured way and there is no ambiguity in data. In order to retrieve the desired data, the user presents a set of criteria by a query. So using query, you can retrieve the data from the database. We have already studied multimedia database in our previous lecture. So all of you know how to create the database, how to store the data information into the database, how to retrieve or how to fetch the information from the database. So in order to retrieve the desired data, the user present a set of criteria by query. So writing queries, you can access the information or retrieve the information from the database. Multimedia data retrieval depends on the type of multimedia file it is, which may be continuous or discrete. Continuous media is data where there is a time relationship between source and destination. Video, animation, and audio are examples of continuous media. Some media is time dependent or static or discrete. For example, normal data, text, single images, graphics, etc. So, today we have completed module 4. We have discussed all the topics of module 4. In next video, we will start module 5. Thank you.